This is the Pearson's Edexcel GCSE Mathematics Paper 2 Calculator Higher Tier paper for the summer June 2017 exam. So let's start with question 1. So it says the table below has the probabilities that a biased dice will land on 2, on 3, on 4, on 5, and on 6. And we're meant to work out the probability or the missing probability. So name our rolls a biased dice 200 times, work out an estimate for the total number of times the dice will land on 1 or 3. So first we need to figure out what 1 is. So we know that the entire probability is going to equal to 1. So we have to add this up. So P1 plus P2 plus P3 plus P4 plus P5 plus P6. So choose a different color. So it's 0.1 plus 0.15 plus 0.09, 0.18 plus 0.17. All of this, okay, subtracted by 1 will give you P1. So our answer will be 0.31 if you use a calculator. And so we want now, so if we roll 200 times, okay, so 200 times roll. So we want P1 or P3. So the or represents sum. So that's 0.31 plus 0.18, which gives 0.49. 200 times 0.49 gives you 98. So this means that you can estimate that if you roll the biased dice 200 times, you will land on 1 or 3 98 times. That's the estimate. Question 2. So it says, on Saturday, some adults and some children were in a theatre. The ratio of the number of adults to the number of children was 5:2. Each person has a seat in the circle or had a seat in the stalls. 3 out of 4 of the children had seats in the stalls. 117 children had seats in the circle. There's exactly 2,600 seats in the theatre. So just a couple of things to highlight. So basically the idea is that we just want to, so on this Saturday, where there were the people on more than 60% of the seats, so that's essentially the exam question, how you must show how you get to your answer. So it basically wants to know, were 60% of the seats, more than 60% of the seats occupied on the Saturday. So the ratio of adults to the number of children is 5:2. So we know that there's going to be 5/7 adults, and we know there's going to be 2 out of 7 children. It's the ratio. And we know that if 3 out of 4 of the children had seats in the stalls, then 1 out of 4, so a quarter of children had seats in the circle. Okay, so first of all, we say 2/7 times 1/4 gives us 1/14, and this is equivalent to the children in stalls. Okay, and this tells us it's 117. in the circle. So 117 equals 1 over 14, because it says it here, 17. So basically 117 times 14 is a total number of people. So that's 1,638 total people. And we know that 1,638 divided by 2,600 times by 100 is 63%. So 63% of seats taken. So obviously 63 is greater than 60. So the answer is yes, on Saturday, more than 60% of the seats were taken. So let's just run through that once more. So 3/4 of children had seats in the stalls. That means 1/4 of children had seats in the circle, because either stalls or circle. And we know there's 2 over 7 parts as a fraction of children, because 5:2 ratio. So 1/4 multiplied by 2 over 7 gives us 114 children in the circle. And we know that there are 117 children had seats in the circle. So 117 is equal to 101 over 14. So 117 times 14 will give us 1,638, which is 100% of the, so this is 100% of the people that were there on the seats. And 1,638 over 2,600 multiplied by 100 gives 63. Although it doesn't really look like a 63. There we go. Percent of the seats taken. Question 3. So the diagram shows a prism with a cross section in the shape of the trapezium. On the centimeter grid below, draw the front elevation, the side elevation of the prism. Use a scale of 2 centimeters to 1 meter. So because I don't have a ruler, please excuse my lines. So let's do the front. So we know that this is 2 and this is 2, 0.5. So it says 1 meter is 2 centimeters, 2 centimeters is 1 meter, and each one of these is equivalent to 1 centimeter. So that's 1, that's 2, so that's 1 meter, then 1.5, then 2 meters, and then same thing here, 1, 2, 3, 4. I have 0.5 here, so that means it's going to be 1 centimeter, and then we draw the line. Brilliant. So of course, when you're drawing this, it needs to be a lot more straight using a ruler, but just for the sake of this, I hope you understand. So drawing the side now. So this is 0.5. So again, half. So there we go. That's the side. Okay, again, make sure you draw your straight lines. Okay, question 4. So again, a lot of information here. Ollie drove 46 kilometers from Liverpool to Manchester. He then drove 61 kilometers from Manchester to Sheffield. Ollie's average speed from Liverpool to Manchester was 70 kilometers per hour. Ollie took 75 minutes to drive from Manchester to Sheffield. Work out Ollie's average speed for his total drive from Liverpool to Sheffield. So we just use our triangle. So we've got distance is given by speed multiplied by time, choosing our triangle. So he went from Liverpool to Manchester, and the time it took him was, it says, so 56 kilometers was the distance, and he was driving at 70 kilometers per hour, which is simplified to 4 over 5, and this is equivalent to 48 minutes, okay, because 4 over 5 times 60 is 48. Right, and then so from Manchester to Sheffield, change color. So Manchester to Sheffield. So it says it took him 75 minutes. So the total distance was 56 kilometers plus 61 kilometers, tells us there. So 117 kilometers. And the total time, well, we know it was 48 plus 75 over 60, so 2.05 hours. So now the average speed is going to be 117 over 2.05 will give us 57.1. So again, let's go through this. We know that we use our triangle. So distance, speed, time. His journey is broken down into two: Liverpool to Manchester, then Manchester to Sheffield. So we want to figure out kilometers over the hours. So we figure out the kilometers first for the total journey, and then the hours for the total journey. So we know that he traveled from Liverpool to Manchester, took 56 kilometers, and he done this over 70 kilometers per hour. So 4 over 5. So in terms of the time, it's 48 minutes, because 4 over 5 times 60 is 48. And then for Manchester to Sheffield, it took him 75 minutes. And then that means the total distance was 56 plus 61, which gives 117 kilometers. And the total time was 48, which we got from here, plus 75, which we got from there, which gives us 2.05 hours because we divide by 60, and this is in minutes. And then the average speed is going to be the distance over the time, so distance over the time, which will give us the speed, and that is 117 over 2.05, which gives us 57.1 kilometers per hour. It says Janie drove from Barnsley to York. This is her average speed from Barnsley to Leeds, her average speed from Leeds to York. Janie says the average speed from Barnsley to York can be found by working out the mean between 60 and 80. If Janie is correct, what does this tell you about the two parts of the journey? Well, it will tell us that the time must be the same, because if she can even out the two speeds, and she says that her average speed from Barnsley to York can be found by working out the mean of 60 and 80, and that means the time must be the same. Question 5. So work out the length of AE. So we have AE here. We know EC. So this whole thing here is 8.1. DC, excuse the badly drawn lines, is 5.4, and then dB 2.6, and they're all in centimeters. Work out AE. So you can see that these two lines are parallel. So we can say 8.1 divided by 5.4 gives you 1.5. That means there's a scale factor of 1.5. So 2.6. So that's the scale factor. 2.6 multiplied by 1.5, 3.9. So we've got 3.9 centimeters. So AC is 6.15. So AC (6.15 centimeters), and it says work out the length AB. So it wants you to work out this length. Oh, no, sorry, not that length. It wants you to work out this length here, AB. So essentially all we need to do is, again, scale factors. 6.15 divided by 1.5, which gives us 4.1. So we have 4.1 here, which is BC, 4.1, and then we subtract that from 6.15. 6.15, take away 4.1, which gives us 2.05. Question 6. So Anil wants to invest 25,000 for 3 years in a bank, and he wants to determine which bank will give him the most interest at the end of the 3 years. So personal bank or secure bank. These are the kind of the deals. 2% for each year, and this one is 4.3% for the first year and 0.9% for the next extra years. So we know that our sort of initial saving is 25,000, and if we go for personal bank, that's going to be 25,000 times by 1.02, because it gives us 2% for each year, to the power of 3, because it's going to be for to the end of 3 years. So if we use a calculator, we get 26,530 and 20 pence. And if we use secure bank, so 25,000, and now we multiply by 1.043, because you get 4.3% for the first year, and then we multiply by 1.009, because you have 0.9% for the extra years, but it's 2 years, so we square it, which using our calculator gives us 26,546.46. So the best one will be secure bank, because we get a little bit more, just over £16 more with secure bank.
So question 7, a number n is rounded to decimal places, 4.76. Using inequalities, write down the error interval for n. So if we say that this is 4.76, if it was rounded, say 4.765, and this one here 4.755. So in this case, you would have had to have 4.755 is less than or equal to n, which is with n being less than 4.765. Question 8. It says the cumulative frequency graph shows information about the heights in centimeters of 60 students. And it says work out the estimate for the number of these students with a height greater than 160 centimeters. So to work out an estimate for the number of these students, you go to 160, go all the way up, and when you hit the line, you can read across, and that to me says about 48. So there are 60 students. So 60 subtract 48 gives us 12. So an estimate of 12 students. Question 9. So it says Kyle reflects triangle A in the x-axis. So he reflects it in the x-axis to get triangle B. So let's write that down. Okay, that's B. And it says he then reflects triangle B in the line y equals x to get triangle C. So y equals x is basically, if this was straight, so reflects it in the line C. So it's going to be reflected here. Okay, so you get line C, and it says Amy reflects triangle A in line y equals x to get D. So different color. If you reflect it, get line D. And then she is then going to reflect triangle D in the x-axis to get E. So this is the x-axis, and she's going to reflect it to get triangle E. So Amy says that triangle E should be in the same position as triangle C. Is Amy correct? So the answer is no, because obviously triangle E is not in the same position as C. Says no. So she would get triangle C if she reflected D in y axis. So basically she would get triangle C if she reflected D in the y-axis. So that's the y-axis, where x equals 0. So if she reflected D along this axis, she would get C. But obviously, in this case, she's reflected D in the x-axis, which is where y equals 0, which is here. Okay, question 10. Write down the name of the planets with the greatest mass. So write down the name of the planet with the greatest mass. So it's the greatest mass here. Well, we can look through. Well, we can tell that this has the most zeros. It's got 4. It's got 27. So Jupiter. Find the difference between the mass of Venus and the mass of Mercury. So the mass of Venus, so it's here, 0.869 times by 10 to the 24, subtract by, here's Mercury, 3.302 times by 10 to the 23. So if we subtract these two, we can just use a calculator. We get 4.5388 times 10 to the 24 kilograms. So C. So Nishat says that Neptune is over 100 times further away from Earth than Venus is. Is Nishat right? You must show you're working out. So let's take the distance of Neptune, which is 4.35 times 10 to the power of 9, and the distance of Venus is 4.14 times 10 to the power of 7. So we can divide those numbers. We get, using a calculator, 105.0724638. So of course that means that this is greater than 100, so it is 100 times further away. Question 11. Solve this. So basically what that means is find x which works for this equation. So the first thing that we can do is that we have fractions and we want to get the LCM. So a multiple that fits in 4, 3, 6 as its factor is 12, so times by 12. We treat this like fractions as always. So 3x minus 2 is going to be multiplied by 3 minus 2x plus 5 is going to be multiplied by 4, and then on this side we're going to be multiplied by 2. Okay, so using our knowledge, so 3 times 3x, 9x, 3 times minus 2, so that's minus 6. So minus 4 times 2x, 8x, minus 4 times 5, minus 20, and this equals 2 minus 2x. And then at this point we just rearrange. Here we expanded. So I'm just going to take my numerical values to the other side and any of my variables to the left hand side. So this is left hand side, this is right hand side, just for me to be able to refer to it more easily. 9x minus 8x plus 2x, that's plus, that becomes negative. Take that to the other side, becomes a plus. So you get 20 plus 2 plus 6. So this gives us 28. And this here gives us 3x. So that means x is 28 over 3. It can't be simplified any further. Question 12. So it says there are 30 students in Mr. Lear's class. 16 of the students are boys. 2 students from the class are chosen at random. Mr. Lear draws this probability tree diagram of this for this information. So 16 out of 30 are boys. If he picks one, then you've got 15 out of 30 boys left. 16 out of 30 are boys, so that means 14 out of 30 are girls. And then if he picks a boy the first time, then there's still 14 girls left remaining. Whereas if he picks a girl the first time, then there's still 16 boys remaining, about 13 girls. So write down one thing that is wrong with this probability in the probability tree diagram. Well, the first thing that I notice is that when he picks a boy, okay, which means there's going to be 15 boys, he doesn't do the same thing for the denominator. He doesn't subtract 1 from the denominator, which he should do because he's already selected someone. So we can say the second student probabilities should be out of 29. So essentially the denominators should be out of 29. So it says Owen and Wasim play for the school football team. The probability that Owen will score a goal in the next match is 0.4, so it's almost half. Probability that Wasim will score a goal in the next match is 0.25, so it's a quarter. So 25%. Mr. Slater says the probability that both boys will score a goal in the next match is 0.4 plus 0.25. Is Mr. Slater right? It says give reasons for your answer. So the probability that Mr. Slater is not right, so no, and that's because the probability that they both score cannot be more than one of them scoring. So the probability of probability of both of them scoring cannot be greater than one scoring. So in essence, it's going to be 0.4 times 0.25, and that will give the probability of that both the boys will score. So both, I'm just going to put O plus W score, which is in essence 0.3. Question 13. The histogram shows information about the ages of 134 members of a sports club. 20% of the members of the sports club who are over 50 years of age are female. Work out the estimate for the number of female members who are over 50 years of age. So the way that we can do this is because of the frequency density graph. That means that we can find the area by multiplying the height and the width. So here each square is worth 2. So we have 10 here. So here is 10. So that means 10 multiplied by, and then as you go up here, you get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 0.5 as you go up. Sorry, that's 0.05. So that means this one here is going to be 1.1. So 1.1 times by 10 gives us 11. Here it's 10. So 10 times, and here we see again, we've got 6, 2.7, 2.8. So that's 2.8. So that's going to give us 28. And then here we've got 20. And we can see we've got here 2.1. So 1, 2.2, 2.3. So 2.3 times by 20 gives us 46. Here we've got 20 again. And then we've got on this side 1.4. So 1.4 times by 20 gives us 28. And then here we have 0.6, 0.7. And here we have, so that's 20. And then that, so this is 90. So the whole thing here is 30. So 30 times 0.7, so that gives 21. So the question says, over 20% of members who are over 50 years old or 50 years of age are female. So years of age, so we've got this one here, so that's 50. So we know that we've got, this is half the area of this bar chart. So that's going to be 14, so over 50 is 14 plus, and then we've got 21. Add them together, that gives 35. And then 20% of 35, because there's 20% of the members, is 7, because it's going to be 0.2 times 35, which is the same as 35 divided by 5, which just gives us 7. So that means 7% of those, so that means 7 of the people over 50 are female. So here are some graphs, and in the table below, match each graph with the letters, match each equation with the letter of its graph. So y equals sine x. So let's have a look through. We'll start off chronologically and make our way. So it can't be this sine, no, it can't be sine x. This one looks like our sine x, and just something that we have to learn from memory. So you can see it's got that cyclical nature, crosses through the origin. So that for me is sine. So y equals x to the power of 3 plus 4x. Okay, so we've got a cubic. So it can't be this one. We've already eliminated that one. Can't be this one, because we're looking for one that has 2 points. So we'll look through. Okay, this one here looks about right. So F is about right to me. And then we've got y equals 2 to the power of x. So that looks like an exponential. So the more that x increases, this will be squared. So that looks about right. Can't touch, can't be equal to 0, because 2 to the power of 0 is 1. So that should be 1 there. So I'm going to go for A. And then y equals 4 over x. So it looks like a reciprocal. So if I say y equals, so at the 1, so if x equals 1, that's going to be 4. So we've already decided that one. So it can't be this, because when y equals x, so when x equals 1, we get y equals 4. So it can't be that one. It's not reciprocal, not a reciprocal. We've already selected this one. No, not reciprocal. Okay, this one looks like it's going to be our answer. So question 15. So it says A, B, C, and D are 4 points on the circumference of a circle, A, B, C, and D. And it says prove that A, B, E and triangle D, C, E are similar. You must give reasons for each stage of your working out. Okay, so A, E, B, so the angle is equal to D, E, C, okay, because they're vertically opposite. So you can see that A, E, B, and we've got D, E, C. So they're equal because they're vertically opposite. And A, B, E, so the angle ABE and ECD are also equal. So that's ABE is going to be equal to ECD. Yeah, maybe a different color will be better. So these are going to be equal angles because they come from the same point. So remember your circle theorem. So because they originate from the same 2 points, these are the same. So angles from same points, so subtended from same arc. Yeah, so that's just terminology. So this is the arc, and they're subtended from the same points, points. So angle BAE is going to be equal also to angle BDC. So BAE is going to be equal to BDC. So essentially that's, I'm going to use the green here, so that one here. So these are the same because again they come from the same points. So again, subtended from the same arc. So same reason above. And then all angles are equal, so therefore all angles equal. So ABE and DCE are similar. So again, because these points here, so A, E, and A, E, and C are a straight line, and we have to prove that A, B, E, and D, C, E. So that's this one here is the same as this one here, or similar I should say, because these angles are the same. Question 16. So using algebra, prove that 0.136 recurring multiplied by 0.2 recurring is equal in value to 1/33. So in this case we can say the following. So let's say that 0.136, just rub that off. So let's say that 0.136 is recurrent equals x, and 1.36 current equals 10x, and then we keep multiplying by 10 equals 1000x. Now similarly for 0.2 recurring y, so 2.2 equals 10y, and then we can say that 10y take away y equals 9y, which equals, from our 2 here we get 2. And then the same thing, so if we subtract 1000x by 10x, that will give us 135. So 990x equals 135. So x equals 135 over 990. And y equals 2 over 9. So this can be simplified to give us 3 over 22. And therefore, if we multiply x by y, we should get 3 over 22 times by 2 over 9, which will give us 1 over 33. And that proves algebraically that this is equal to the value 1 over 33. Question 17. ONQ is a sector of a circle with center 0. So ONQ with radius 11. So all of this has radius 11. A is the point ON, and B is the point on OQ, such that OAB is an equilateral triangle, excuse me. So seven calculate the area of the shaded region as a percentage of the area of the sector ONQ. So give your answer to 1 decimal place. Okay, so the sector area is going to be, so we know that we have 60 over 360. So this here is going to be 60 over 360 because we know it's an equilateral. So 60 times by pi 11 squared, because remember we have the area equals pi r squared. We have 1/6 of a circle, so times by pi times by 121 centimeters squared. And the triangle area, which is ultimately what we're going to subtract from the sector area, is going to be a half times the height, half times A times B sine 60. So ultimately the area of the triangle is half times A times B times sine C. Just a formula that you will need to know. And then this gives us, using our calculator, 21.21762239. So we know that the shaded area is 121 pi over 6. Subtract our answer, 21.21762239, divided by 121 pi over 6. Ultimately this is the divided by the area times by 100, and that will give us, using our calculator by putting that in to 1 decimal place, 66.5%. So 66.5. So again, let's just go through that. We know that this is an equilateral triangle with the sides equating to 7. So we have angles equating to 60. We know that this is 11. Our job is to find the area of the shaded region. So we can find the area of the entire sector by finding the area of a circle, multiplying by the percentage or the proportion of the circle that this sector represents, which is 60 over 360, which is 1/6 of a circle if you simplify this. And then you want to find the area of this triangle to subtract it from. So remember, we have half times A times B times sine C, which is triangle area. Substitute in all those values, find that area, and then you just subtract the triangle area from the sector area over the sector area times by 100 to find the percentage, 66.5%. Okay, question 18. Work out the exact value of x. So in this case, 16 is 2 over 4 and 8 is 2 over 3. So we can say, instead of 16, writing 2 to the power of 4 to the power of a fifth times by 2x equals 2 to the power of 3 to the power of 3 over 4. So again, just the normal laws of indices. So you get 2 to the power of 4 over 5 times 2 to the x, so it should be x, equals 2 to the power of 9 over 4. And then we can simply get rid of or ignore our bases, so the bases. So we now law of indices, 4 over 5 plus x equals 9 over 4. So law of indices. And then we can take this to the other side. X equals 9 over 4. Take away 4 over 5. And then using a calculator, we get 1.45. So x equals 1.45. So again, changing 16 and 8 to a base value 2, and then writing out its power respectively, substituting it into the equation, which will allow us to use a law of indices to get rid of our brackets. And then we can use the law of indices again to then start rearranging to allow us to get the value of x. Question 19. So it says 2 minus, and then you have these fractions, can be written as a single fraction in this form where a and b are integers. So work out the value of a and the value of b. So this is going to require quite a bit of working out. So I'm going to use my other software. So we had 2 minus x plus 2 over x minus 3 minus x minus 6 x plus 3, and we want it in this format. So we have to find a and b. So the first thing that we can do is turn this 2 over 1, and then similarly as we've done before, we can try and find the LCM. So in this case, we can say, well, 1 times by x minus 3 multiplied by x plus 4 is going to give us the LCM. So we can write out equivalently x plus 3. So again, we're just using the same principles as those from the LCM procedure. So x minus 3, x plus 3. So basically, if we were to revert to one step back, we would be able to get our original equation, x minus 3, x plus 3. So you know, if you cancel these, if you cancel that, and if you cancel these, you can revert back to what we have on top here. And then now it's a simple case of just expanding. So again, this is just a simple case of going through all of the terms and expanding out. And one of the things you have to be careful here is that you don't make any silly just procedural mistakes, which can be sometimes the main difference between a different level, mathematically speaking, in your results. So it's good to go through these types of questions to iron out the creases, so to speak. This is all over x minus 3, x plus 3. And then we can just start to see that we get, again, we can start to simplify. So, and then, so here x squared minus 9 minus 1, x squared plus 5x plus 6 minus x squared minus 9x plus 18. So again, just simple case of going through this, as I said, expanding, simplifying. So here, so first step, first use LCM protocol. So that's number 1. So you can say this is number 2, you can say this is number 3, and then same thing, simplifying, and then expand out. So you get 2x squared minus 18 minus x squared. So here we're just expanding out of the bracket, so we're not doing anything too tedious. So 4, so we're expanding, and then you can see that we are getting closer and closer to a desired result. And then 4, if you simplify, so simplify once again, you'll get 4x minus 42 over x minus 3, x plus 3. So if we look here, we can see our ax plus b over x squared minus 9. What you notice here is that this is a sum, or the sum of two squares, 4x minus 42. So it can be written as x squared minus 9. So that's the so the difference of two squares, and therefore you can see that we've got it in the format that we wanted. So a is equal to 4 and b is equal to minus 42. So you can see there, just following simple procedure of find the LCM, the fractions, treat them as such, expanding, simplifying, expanding some more, simplify once again, and then you can see that this is the difference of two squares, and it gives you a 4 for a and b for minus 42. Question 20. So it says the diagram shows part of the graph of y equals x squared minus 2x plus 3. By drawing a suitable line, use your graph to find the estimates for the solution of y squared minus 3x minus 1. Right, so because I don't have a calculator, a ruler, you're just going to have to bear with me on this one, because the line will not seem so straight. So if we take this equation here, then we can say that if we split our equation here, so x squared minus 2x minus x minus 1 equals 0. We take this to the other side, x squared minus 2x minus 1 equals x, and then we do the same thing with the minus 1. So I'll write this up here, x squared minus 2x, and then we can say excuse me, plus 3 minus 4 equals x, because if we revert if we compute these two, get -1, x squared minus 2x, then we have plus 3 equals x plus 4, because we take that to the other side. And then so we can say that if we have this equal to y, so y equals the following, which we've written out here. So that means that y equals x plus 4. So when x equals 0, 1, and 2, our y equals 4, 5, and 6. And so we can plot that out here. So when x equals 0, y equals 4. Apologies once again, it's not straight. When x equals 1 equals 5. And then when x equals 2 equals 6. And so on and so forth. Now again, because I'm not using a ruler, this may not be as accurate as if you were using a ruler, but hopefully you understand where I'm coming from. But essentially, if you cross the line using a proper ruler, you'll notice that the points at which they intersect are going to be minus 0.3 and 3.3. And again, because it's not the most straight of lines, but you'll be able to estimate about those points where it crosses with the curve. So it says for B, calculate an estimate for the gradient of the line at P, of the graph at point P. And it says P is the point on the graph y equals x squared minus 2x plus 3, where x equals to 2, which is here. So where x equals 2, and we can try to figure out the gradient. So again, this is all about having a ruler, but essentially if you were to draw out accurately, you will have a height 3 and a length of 1.4, and then you can use this 3 over 1.4, which is the rate of change, which can be written as 15 over 7 to get rid of this decimal in the fraction, which gives us 2.1 to 1 decimal place. Now, obviously, because you're estimating, this can be slightly different in value. So you can have anything from 1.6 to 2.5 as a sensible / reasonable answer. Okay, so question 21, you have 3 identical circles inside a rectangle, and it says each circle touches the other 2 circles in the sides of the rectangle, and it says the radius of each circle is 24 millimeters. Work out the area of the rectangle. So this is going to be 24. So we can start off by figuring out the sides of the lengths of the rectangle. So it's 24, that's 48. This is another 24, that's 48. So we have 96. Goes across here. We know that between there and this is going to be 24, and between, so coming up to this, from that point there to there is 24. So we have a triangle which is going to be in there. It's an equilateral triangle. So we know that this is 48. This is 48. and this is 48. We have a right angle at this point here, and this is x. So you can say 48 squared equals 24 squared plus x squared. So again, to figure out the height, we use Pythagoras, because we have a right angle. So using our calculator, we get 2,304, 576 plus x squared, and then at this point we just take this to the other side. 576 equals x squared, which gives us 1728 x squared, and then we get 24 to the square root 3, which equals x. So we know that this height here is going to be 24 square root 3. So therefore we can just add this length here and multiply it by this. So we get 24 plus 24 square root 3 plus 24 times by 96. It's going to be length times width. And then if we use our calculator, we'll get 8,598.645061 millimeters squared. But if we want that to 3 significant figures, as the question requests, then we're going to get 8,600 millimeters. Okay, so again, just to go through that, so we've got 96 here millimeters, because we know this is a radius, so 24, 48, and another 24, another 48, so altogether 96. We know from this point to that point is going to be 24 because it's a radius. It's 24 there, and same thing here, we know that from this center here to that point is 24. So the only thing to calculate is this length here, this height here, because we have a triangle that can be constructed in the middle. We will end up with a Pythagoras opportunity. So this is 48, this is 24, and then we have here a right angle, so we can use Pythagoras, which we did to calculate this length here, which corroborates with the height, which gives us 24 square root 3, and then we just add all the heights here together, and this is our width, and we multiply them as per the area to get our answer, and then we change it to have 3 significant figures. Question 22. It says, here are the first 5 terms of a sequence. Find an expression in terms of n for the nth term of the sequence. So let's just write them out. 4, 11, 22, 37, 56. So we have here difference of 3. So you can see a plus b plus c. So we have a difference here of 3. Difference here of 11. Difference here of 15. Difference here of 19. And then here difference of 4. Difference of 4. Difference of 4. So we have 3a plus b. And here we have 2a. So 2a equals 4, which means that a equals 2. So 3, so we're using this one now. 3a is 2 plus b. So 6 plus b. Oh, and this equals 7. So equals 7. So b equals 1. And then we have 2 plus 1 plus c equals 4. So that would mean 3 plus c equals 4. So c equals 1. So therefore we're going to have Remember our general expression looks like this. So we're going to have 2n squared plus n plus 1. And that will be our answer. So just to reiterate, so we have a plus b plus c. Here we have 3a plus b. And here we have 2a. So we just work out the difference between the first step, difference between the second step, and difference between the third step. And then you can see that we have 2a equals 4. And then 3, so we get a equals 2. And then we have 3a plus b, so we put the 2 in for our a, which we just found out, plus b, so we know that b equals 1. And then we do the same thing for it's a plus b plus c, so 2 plus 1. So that's our a, that's our b, plus c equals 4. And then 3 plus c equals 4, so c equals 1. And then remember our general equation, our general expression looks like this. So we just sub in our value for a, sub in our value for b, sub in for our value for c. Question 23. So it says L is the circle with equation x squared plus y squared equals 4. Point P is a point on L. Find an equation of the tangent to L at the point P. So basically, if you have for instance, a circle, okay, and it should probably be more centered than that, but essentially you have a circle and it's centered, and you take the radius, and then you have a tangent which touches at the point, creates a right angle. So this is the point P at 3, 2, square root of 7, 2. So that's the point P on the tangent L. So this is the tangent L. Just going to put x there, put y there. Right, so first thing that we need to do is, so this is from O to P, so this is our O, is going to be square root of 7 over 2, take away 0, 3 over 2 equals 0. So we have square root of 7 over 2 divided by 3 over 2, which gives us square root of 7 over 3. Remember, because it's a perpendicular gradient, if you recall the rule that a times b must equal minus 1, so that means that the gradient of the line L is going to be, of the tangent L, is going to be minus 3 square root of 7. So this also equals minus 3 square root of 7 over 7. You can write it either way. Let's continue on here. And then we know y equals minus 3 square root of 7 over 7 x plus c. Remember, we have our point P here, so all we needed was the gradient and the point P. So we said 7 over 2 minus 3 square root of 7 over 7, and then x is 3 over 2 plus c. And then here now all we need to do is just some rearranging. So if we rearrange, so square root of 7 over 2, we have minus 9 over 7, 14 plus c. And then take this to the other side, square root of 7 over 2 plus 9 square root of 7 over 14 equals c. And then we literally just change to have the same denominator, and so we'd have 7 square root of 7 14 plus 9 square root of 7 14, which gives us 16 over 7. 16 square root of 7 equals 14, that should be, and then if we divide by 2, so we get 8, and then we get 7, so we have 8 square root of 7 over 7 equals C. So that means that y, we've done quite a bit here, is going, so y, so the equation of the tangent L is going to equal minus 3 7 over 7, so minus 3 square root of 7 over 7 x plus 8 square root of 7 over 7. So that is the equation of the tangent L. So let's just go through that very quickly. So we want to find the equation. We need to know 1 point plus the gradient to find the equation of a line. So we know our 1 point, which is P, which is given to us, and we know that this is a circle. So if we draw any circle, we know that the tangent is going to touch, and we're going to have this right angle formed between the tangent and the line drawn from the origin, from the center. And then so we know that the perpendicular gradient, is going to be A times B equals 1. So that's the gradient of the line, so we can say this one, and the gradient of this line. This is just a rule that we have to memorize. So we found that it's minus 3 over square root of 7. We rewrite it in a different format so that it aligns with our so that it allows us to formulate our equation of the line with our y, which has a third square root of 7, and then we just follow through with our calculations and we get our C, and then finally we can write everything as follows. And that brings us to the end of this paper.